Hello, ladies and gentlemen, and welcome to another episode with Electronics with a Drink. I am Ross, your host today. Today's drink is empty, and it was a Bacardi Gold with a Diet Coke Lime, and I am using a straw because I busted my lip and don't want to put my lip on the glass because it hurts. So today, what I'd like to talk to you about are two pieces of software that I use on the ESP8266. One is the interface, and one is the actual software that is used on the 8266 to interface with the software. The interface itself is web-based, and it is called Domoticz. It's spelled D-O-M-O-T-I-C-Z. And the software that is used on the ESPEasy, or the ESP8266, is called ESPEasy, and it is uploaded to the actual memory on the ESP8266 and has a interface that is configurable, and between Domo and the ESP8266 software, ESPEasy, you can use it to monitor or control devices within your home network. So the first thing I'd like to do is I'd like to go to the Domoticz website and show you what they have available for you. So this is the main page. It's a gentleman out of Spain, I believe, that has created this software. On the main page, you see it's free open source, and it shows you the different devices that you can actually use with the software. The manual is a PDF formatted document. This one was updated in 2015. It probably needs a little bit of an update, but the guy that does it, this is his hobby. I've actually donated a few dollars to him to continue his build of the software. There was a recent update in late 2016 that I updated to, which has made it really stable. If you go through the table of contents, it shows you all the different sections on how to set it up, what you can use, why it's used, and interfacing for external third-party type devices or software. For instance, I plan on interfacing my SMAPI device with Domo to make it easier to control, because right now what I have is on my iPhone I have two different pieces of software on there. One is used for Domo and the other one is SMAPI. So the SMAPI device, what it does is it measures your power consumption, water consumption, and your gas consumption. It can also be interfaced with solar panel integration to measure how much power you're actually producing. I don't have it hooked up right now because I haven't had time. So in future episodes, I'll show you how to do that. But this episode is basically showing you the Domo website, the different information that is available, and a brief overview of how it looks. So as you see through the manual, it's very comprehensive, has a lot of information of how to set up a Domo server inside of your house instead of using an MQTT broker similar to Cayenne. That's one of the drawbacks. I do not like using Cayenne for my home automation because it is an MQTT broker. Definition. MQTT broker basically means that the information that is sent from your house is sent out past your firewall. The MQTT broker on the other end hosts the information and then makes it available outside of your firewall. So for instance, I have the Cayenne website interface or the app on my phone, and what I was able to do in the past when I had it set up was go into the Cayenne software and then control my devices or see temperature settings, etc. Through LTE connection. I don't do that anymore. My Domo server is set up to only interface when I'm at home or when I VPN from my phone into my actual home network. So let's go briefly to the internal Domo website interface that I have currently running inside of my house. And as you can see, I have very integrated devices. This is just the dashboard. The dashboard is items that you've selected to be shown in all of these devices I have shown. I have a lot of switches. I have a lot of temperature and humidity sensors for the house. And then I have about 5 light sensors, which lux shows the amount of lux for each of the devices that I have. Now, each one of these sensors is put inside of a box that I 3D printed out. And I'm not sure if you can see this very well, but this is a prototype box that I built. It has a fan, DHT22 inset, and then vents for the device to breathe. I've also created these type of controllers, which has the fan built into it, and then it has 220 plugs, and then a switch on the back. This one is not finished. Pretty integrated, but all of my devices feed off of, or inside of these 3D printed boxes, which is really nice. Most of the boxes have 3 to 4 sensors. I've got PIR sensors, I've got temperature, humidity sensors, and then I have light sensors, and then I also have some that are filled with actuators, i.e. relays, for lamps or for any kind of appliance. Depending on the appliance, I use between a 10 amp relay and a 30 amp relay. And most of the boards I build myself, which I'll show you right now. Currently what I have is this board is used for a 30 amp controller system, and it has 1, 2, 3, 4 relays, and it uses the ESP12E to control it. Now I have one of these built. It's upstairs running my entertainment center, and it also has an RFID, it has it has a RF antenna, and it also has an IR antenna, or an IR sender receiver, and that's used to control the devices inside of the entertainment center, i.e. the TV, Apple TV. The RF is used for the Fire TV, and then I've got an RS-232 connection that goes to my amplifier. So this is the dashboard. You've got multiple tabs up top. These are the switches is broken out to each one of the switches that is built or is configured inside of the system. You notice I have a lot of them here. Some of them aren't hooked up right now because I haven't finished some of the devices. The entertainment center is finished, but they're not actuated. Then I have these MBR motion. Now what I had to do is on the PIR is I had to make it to where the input on the ESP8266 was set, and the PIR actually sends a signal to that input and then sends it back via an IDX number, which I'll show you shortly. Then we have scenes. We have the downstairs lights, and basically what this does is it groups the different items. In this case, it's switches. I have 3 switches grouped together, and it's set off by a timer. So when I am not home or during the day, what it does is it actually sets, it's set up to where during the day they turn on at a certain time and they turn off at a certain time. Let's go back to the scenes, and I have also my lab power, which has two 10 amp relays, and then all lights, which is all the lights in the house turn on. Temperature sensor, these are all my temperatures. Usually it's a DHT22 or a Dallas DS18B20 type sensor. Weather, you can use weather stations to connect to it. And then utility, the ones in red are not activated. It's not seeing them, so they're painted red. That basically tells me that there are no signals coming from those devices. The ones you don't see in red are actually lux sensors, which are the analog light sensors, and all of them are active and all of them are accurate. So in the setup hardware, these are all of the different controllers that I have in the house. So when I set that up, I have to set up, in this case I'm using dummy sensors. I use get commands at each one of the devices, and I'll show you that. So these are the actual on action, off action, and they're get commands. So what it does is it basically sends this via HTTP to the ESP8266 to actuate GPIO for on or for off. So once you get your controller built, and in this case you would just come down here and select dummy does nothing, used for virtual switches only. You create that virtual sensor, and then what it does is it asks you what that sensor is supposed to be. You give it a name, temp, and then you hit OK, and it creates a dummy sub-switch interface for that device. So we go back to setup, where all of your devices are located, and we'll go to, we'll look at the different sensors. For instance, this is my attic sensor. I have 1, 2, 3, 4, 5, 6 different interfaces, and they have IDX numbers. These IDX numbers interface with the ESPEasy software, which I'll show you in a minute. And all of these devices are up and running. They're actually receiving information. If the motion sensor is tripped, it sends via IDX 54 to the dashboard if there is movement, and you can do triggers and different if-then commands inside of the software. It's really, really nice. I really like the Domo software. The guy really did a good job to it. In short, you've got IDX hardware ID, units, name, and so on and so forth. It's different information that's located in the Domo settings. Now, this is the settings for the actual global commands. Right now, of course, local networks, I only have it set up to where it's internal, so nothing outside can actually come in unless it's on that .44 network. Notifications, you can use Prowl for iPhone, iPad. You can actually set up SMS, Clickatel, which is a service you can get to send you SMSs if something is triggered, which is great for an alarm system. So if you have contacts, magnetic contacts on your doors, you can hook this up, and if it triggers a signal, it sends you a message immediately. I've got my email set up to where it sends me information if I need to. You can set it up to where you've got meters and counters. For instance, I'm going to integrate my SMAPI into this system, and to do that I'm going to have to write a bit of code to fulfill the requirement to get the parameters correct. You can design a floor plan and then show in that floor plan where each one of these devices is located. Other random timer, sensor timeout, stuff like that. It's very standard type stuff. Raspberry Pi camera parameters, which I don't use, which is fun. And then a backup restore. The backup and restore is really, really nice, and I've automated this to where it backs up to my NAS. So if for some reason the Raspberry Pi 3 that is running this server currently dies, I can do a full restore with no problems. So that is the Domo interface for the software running on a Raspberry Pi 3. So now I'd like to go to the Let's Control It website. And let's just take this out. So this used to be called ESP8266.NU. These are a bunch of individuals that are out of the Netherlands. It's a Dutch consortium of individuals, and they've done a really good job on the software. The website, it's alright, but it's not perfect, but it gets the point across. So when you scroll down to ESPEasy, give it a quick read. They started out investigating Node MCU with Lua. I haven't used Node MCU yet, so I'm not familiar with it 100%. But this is key right here. Remember that our primary directive is to enjoy prototyping with stuff like the ESP. Feel free to join in. I have yet to contribute to them, and I plan on doing it once I have a solid understanding of what they're trying to do and how to build into their or integrate systems into the ESP8266. But in the meantime, I've used their software, and I've donated to them as well because what they're doing is really well put together. So when you go into the wiki, you've got stable projects, and the ESPEasy is what I'm concentrating on today. RFLink and Nodo, and then experimental projects. I have not delved into that yet, and I don't plan on it because of time constraints in my personal life. So we go into ESPEasy, and once you get in there, it's very similar to how you've seen Wikipedia. It's the same open source website software that they've used here. Introduction, very similar. They're currently using build R120. On some of my devices, I'm using R108. Stable, but it doesn't have the features that R120 has, and the I2C interface is a little bit better in R120. So these are the different applications you have. You've got sensors input. You've got pulse, temp, lux, barometric, humidity, RFID, etc., etc. What's really nice about this is you can interface the ADS 1115, which gives you 4 analog inputs instead of just the 1 ADC analog input you have on the ESP826607 or 12E through F. IR receivers, digital inputs, the 23017, and then the actuators. You can use relays. You can use servos, and then also the NCP 23017, which runs on the I2C bus. What I have on most of my controllers, I have is an OLED screen on them to see the information, so I don't have to go to the website. I just look at the actual device. I've got it set up right now where I've got temperature, humidity, the onboard temperature, and then also the time, the IP address. What else do I have? And in this case, in my controller that's inside of my office, I have the switch 1 and switch 2, which shows me if it's on or off. It is 1 or 0. So using the flash load, using the Arduino IDE to upload the EZ firmware. This gives you a quick tutorial on how to set up your Arduino IDE to accommodate the ESPEasy software. Very basic. Gives you a rough outline of what you need to do. The only problem with this is they don't have it based on the Mac PC. They have it based off of Windows PCs, which is fine. You just have to kind of navigate. The navigation is very similar to the Windows for the Mac. So just read through that. Gives you a good understanding of what you need to do. And the other thing that I wanted to go over was the software, which is located down here in the stable version. This is currently firmware image R120. Now, once that is downloaded and you're configured on your Arduino IDE, you basically do the same thing that I did in my last video, isn't that it's connected FTDI to the actual ESP8266, and then what it does is gives you a web interface similar to what you're seeing here. Now this is my lab controller, and what you're seeing is information that is real time, and this is the second piece of configuration that you need to perform outside of the initial, which I'll show you shortly. So before we even do that, let's do that. Let's go over to the Arduino IDE and look at the software in digits form or code form. So the top of the web page basically gives you a rundown: copyright, blah blah blah. This is incorporated, blah, this and that. Gives you a simple rundown of what it supports. Experimental, okay, sure, whatever. And then the user-specific configuration. Now, the user-specific configuration is only for certain or very basic items. The default name, the SSID, the key, the server that you're connecting to. In my case, .10 is my Domo server, which it's sending information to. And then you've got your, if you're using static IP, a dynamic, you put false. In this case, I'm putting true and I put statics in there. Default protocol. In my case, I am using Domo HTTP, so I've put 1. This is 0 unit in that set. And then feature time and SSDP, I've just left those alone, as well as the ADC VCC. So once you do that, you do a compile and you load it up onto your ESP8266 via the FTDI cable, and this is what you'll see once you reboot it and you've gone to the IP address that you assigned it via website. Your main shows you basic information on the status of the system. The configuration is where you can further configure your user password, ESP IP. You can change all of this stuff if you need to. The hardware, this is the pin breakouts. You can set them up according to what you require them to be. Input, output, default. The outputs you can go low or high. Now, as we did on our last video, I showed you how to incorporate pins, GPIO pins 1 and 3 on the ESP8266 for output or input. You cannot do that through the ESPEasy default software. If you want to do that, you'll have to change some of the software, but I have not done that and I won't do that. So that is one of the drawbacks about using the ESPEasy software. You cannot interface GPIO 1 and 3. And as you see, SDA and SCL it's grayed out, so you can't use them. So going over to the devices, we now see the different items that are interfaced on my lab controller. I have an analog input, which is a lux sensor or a light sensor, photocell sensor. I have a DHT, which is my temperature humidity, as a DHT22. I have a DS18B20 on GPIO 10, which I've had no problems using. And then the OLED, it's a 1306, which is running on I2C on GPIO 5 and 4. When you go into these devices, and we'll go into the OLED section, this is the screen configuration of what you want to show on it. In this case, you have a total of 8 lines that you can show information on the 1306 screen. Won't go any farther than that. You can do display timeout, so if after a while it'll go blank. So IDX and VAR. IDX I set as 1 as a default because it needs something there. It can't use 0. And then delay is 1. So that means it updates every second. What the device status is. So let's go to temperature humidity, the DHT22. So I've got this hooked up to GPIO 12. And as I said before, you'll see there's 63 here. Now that's the IDX number that is set up in Domoticz or Domo. So we go to temperature. Let's go to setup devices, and then we'll go to lab controller. So you'll see down here that 63 is my temperature and humidity. And that's the IDX variable that it's using. 63. And that's where the information comes from to feed the Domo server or website interface. This is sent every 1 minute to Domo, and Domo then processes it and puts it up inside of the interface to show the user. So, and then we have, of course, the DS18B20. We have analog. Those are the only devices I have hooked up to this thing. Those are not functioning right now. The switch inputs, those are there for the screen. It's only to make it to where the screen interfaces, because I needed a name to put into the actual line to show its status. In this case, SW1, this will show either 0 or 1. I couldn't get it to do on or off because the code will not allow you to put 1 equals on or 0 equals off. So that's a quick rundown of the system itself in a whole. The ESP8266 has a lot of possibilities, and these two pieces of software make it even easier for the normal user to come out and say, I've built an IoT. So with that being said, I would like to say thank you for watching, and if you have any comments, please do put them down below, and I am welcome to suggestions on what we should do next. Thank you for watching, and see you next time. Have another drink.